Hey guys, how you guys doing? Today, what we're going to be doing is learning 2.6, perimeter and area of similar figures. What we should have learned in previous sections in the last couple of days is that similar figures are the same shape, different size, the angles are congruent, and the sides are proportional. And we're going to continue the same concepts, but we're going to add some stuff regarding perimeter and area. In order to do this, we need to do some review. The first thing we're going to review today are squares. If you guys don't remember what a square is, it's basically when you multiply a number times itself. For example, 1 squared, or 1 to the power 2, is 1 times 1. So, 1 squared is 1. For 2 squared, that means 2 times 2, which is equal to 4. 3 squared means 3 times 3. What I want you guys to do right now, at this point of the video, is pause the video. I want you guys to press pause, and I want you guys to finish this page. So press pause. All right, guys, you guys should have finished this page. Let's see if you guys got the right answers. So for 3 squared, it's 9. For 4 squared, it's 16. 5 squared is 5 times 5, which equals to 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. I hope you guys got all this because it's really, really important that you guys remember and memorize these squares. All right, let's go to the next slide. So, I want to review really quickly about area. So, who remembers what the formula for figuring out the area of a rectangle is? If you guys don't recall, area of a rectangle is equal to base times height, or simply A equals BH, or area is equal to length times width, or simply A equals L times W. I'm hoping you guys are copying these notes onto your paper notes. If you haven't done so already, please press pause now before we go further. All right, guys. I want you guys to look at this example for area of a rectangle. I want to figure out the area of this particular shape. We know that the base is 6 meters, or the length is 6 meters, and the height is 4 meters, or the width is 4 meters. How do I figure out the area of this particular shape? I want you guys to do this right now, and I want you guys to do it on your own. I want you guys to press pause on right now. Please press pause. Work it out. Okay. Let's see if you guys got the right answer. So I know that the formula for area of rectangle is base times height. I simply multiply the base of 6 times the height of 4, and I get 24 square meters as my answer. A short way of writing that is 24 meters squared. Remember, for area, it's measured in squares, and this is how we normally write it, 24 meters squared. All right, let's go on to the next slide. Ooh, you've seen a problem like this before. X over 25 equals 6 over 10. I want to solve this proportion. This is very, very important before we go further, because you guys should know how to do this. From what we talked before, we can solve this by first simplifying up and down or left and right. Please solve this right now. Press pause. After you finished it, press play again. All right, guys. From what we've done before, again, we can simplify this up and down, left and right. I'm going to first choose by simplifying left and right. I know 5 is the biggest number that goes into 25 and 10. 25 divided by 5 is 5. 10 divided by 5 is 2. At this point, I'm going to simplify up and down, 6 and the 2. The biggest number that goes into 6 and 2 is 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Now at this point, I will cross multiply. 1 times x is x. 5 times 3 is 15. So the answer for this particular problem is x equals 15. I'm hoping you also got this, since you've seen this problem several times. All right. Now is the heart of today's lesson. What we're going to be doing is making some conclusions after we do several problems. Okay. I want you guys to take a look at this problem. I have similar shapes. A, B, C, D is similar to W, X, Y, Z. The sides are already given to me. Let's look at the first question on the left side. It says, pick 2 corresponding sides, left to right. What is the ratio of the sides? Simplify if needed. What I'm going to do is I'm going to pick 9 and I'm going to pick 6. So I'm going to write the ratio of the 2 sides that are corresponding is 9 to 6. Could I have chosen 15 and 10? Yes, I could. But I'm choosing simply just 9 and 6. So what is the ratio of these 2 sides? 9 to 6. I should simplify this. What does 9 to 6 simplify to? It simplifies to 3 to 2. Okay? That's the answer for the very first problem. Now, the next thing it says is, what is the ratio of the perimeters of both shapes? Well, if you guys don't remember what perimeter is basically when you add up all the sides together. And then I'm going to simplify if needed at the end. So let's find the ratio of the shape on the left-hand side. So that's going to be 15 on the left side. That's also, I'm sorry. That's going to be 9 on the left side. That's going to be 15 on the top. So what I'm going to do is just simply add them all together. 9 plus 9 plus 15 plus 15. What is the perimeter of the shape? 9 plus 9 plus 15 plus 15. 9 plus 9 is 18. 15 plus 15 is 30. So altogether, it adds up to 48 inches. Inches. It's length, guys. Perimeter is length, so it's inches. So let's go to a right-hand shape. Let's find a perimeter of this shape. The left side should be 6. The top should be 10. Let's add everything together. 6 plus 6 plus 10 plus 10. 6 plus 6 plus 10 plus 10. What's the perimeter of the right-hand shape? 12 plus 20 adds up to 32 inches. So the perimeter of the left shape is 48 inches. The perimeter of the right-hand shape is 32 inches. Now let's answer the question on the right. It says, what is the ratio of the perimeters of both shapes, left to right? So I'm going to do that right now. I'm going to write the ratio of the perimeters, 48 to 32. Now it says, simplify if needed. I'm going to simplify this. I think the biggest number that can go into 48 and 32 is 4. Is there a bigger number? I think there is, but I'm going to just try 4. So I'm going to divide the top and bottom by 4. 48 divided by 4 is 12. 32 divided by 4 is 8. Oh, can I still simplify this? Yes, I can. I think 4 can also go to both of these numbers. 12 divided by 4 is 3. 8 divided by 4 is 2. That's my answer. 3 to 2. So I want you guys to take a look at the very last question at the bottom of the slide. What do you notice about both of these answers? Well, the ratio of two corresponding sides on the left-hand side is 3 to 2. On the right-hand side, I found out that the ratio of the perimeters of both shapes is also 3 to 2. So what do you notice about both of these answers? I'm going to write the ratios are the same. If I just take the ratio of the sides, it's just 3 to 2. If I take the ratio of the perimeters, it's also 3 to 2. They're exactly the same. Now, is this always true? Are the ratio of the sides always going to be the same as the ratio of the perimeters? Let's check it out with the next example. All right. So let's go to this particular one. It says pick two corresponding sides left to right. What is the ratio of the sides? For this particular one, I'm going to pick the easiest one. I'm going to pick 3 to 2. Can I simplify that? Nope. I'm going to leave it as is. Now, it says on the right-hand side, what is the ratio of the perimeters of both shapes, left to right? Simplify if needed. So let's find the perimeter of the left-hand shape. That's 9 plus 9 plus 3. 9 plus 9 is 18, plus 3 is 21. So the perimeter of the left-hand shape is 21 centimeters. Let's figure out the perimeter of the right-hand shape. Oops. The right-hand shape, that's 6 plus 6 plus 2. 6 plus 6 is 12, plus 2 is 14. So the perimeter of the right-hand shape is 14 centimeters. So what is the ratio of the perimeters then? Well, the left-hand one is 21. The right-hand one is 14. Let's simplify this. 21 over 14. What goes into both numbers? I think the answer is 7. 21 divided by 7 is 3. 14 divided by 7 is 2. Let's see if this is the same as what we did on the previous slide. I found out that the ratio of two sides is 3 to 2. Now, after I calculated the perimeters of both shapes, I found out that perimeters is also 3 to 2 after I've simplified. So what's the answer to the bottom question? What do you notice about both of these answers? Just like the previous slide, they are both the same. The ratio of the sides is 3 to 2. The ratio of the areas, after I've simplified, is also 3 to 2. They're exactly the same. One more example with perimeter. This is a little more difficult. Let's see if you can get this. Let's start off. Pick two corresponding sides, left to right. What is the ratio of the sides? Simplify if needed. Okay. I'm going to choose two sides. I'm going to choose a smaller one. 15 and 12. What's the ratio of these two sides if I simplify it? What's the biggest number that goes into 15 and 12? I think the answer to that is 3. So 15 divided by 3 is 5. 12 divided by 3 is 4. So again, I picked 15 and 12 as my two corresponding sides. Could I have chosen any two sides? Yes, I could. But I just chose the smallest one. It's easy. So I know that the ratio of the two corresponding sides I've chosen is 5 to 4. Okay. Now, what I'm going to do is answer the question on the right-hand side. It says, what is the ratio of the perimeters of both shapes? Left to right. Let's figure out the perimeter of the left-hand shape. 15 plus 20 plus 25. If I add all those together, 15 plus 20 plus 25, my answer is 60. What's the perimeter of the right-hand side? Well, that's 12 plus 16 plus 20. What is 12 plus 16 plus 20? Well, the answer to that is 48. Now what I'm going to do is figure out the ratio of the perimeters. Okay, the left-hand perimeter is 60 yards. The right-hand perimeter is 48 yards. What should I do with this? Yes, I should simplify. So I'm going to simplify 60 over 48. What goes into 60 and 48? I think 4 goes into 60 and 48. 60 divided by 4 is 15. 48 divided by 4 is 12. Can I simplify even further? Yes, I can. Because 3 goes into 15 and 12. What's 15 divided by 3? 5. What's 12 divided by 3? And that's 4. At this point, I'm hoping you guys find a pattern. And it's a point of this part of the lesson. What do you notice about both of these answers? Well, as you guys can see from what I boxed, the ratio of the two sides is 5 to 4. What's the ratio of the perimeters? It's also 5 to 4. They are the same. So, if I asked you what the ratio of the perimeters are in any shape, all you have to do is figure out the ratio of the two sides. Why? Because you'll get exactly the same answer. The ratio of the sides is exactly the same thing as the ratio of the perimeters. That's it. That's the connection between the ratio of the sides and the ratio of the perimeters. Was that easy? I'm hoping it was. Now, we're going to go to something a little more complicated. It's sides and area. It's a little different. It's not as easy as what we just did before. So, what we're going to do is do something very similar, but this time we're going to do it with areas. So, let's look at the very first question on the left-hand side. It says, pick two corresponding sides, the left or right. What is the ratio of the sides? Simplify if needed. Okay. So, I'm going to pick the two smaller ones, 9 to 6. What should I do? Simplify it. What's the ratio of those two sides if I simplify it? Well, I know 3 goes into both of them. 9 divided by 3 is 3. 6 divided by 3 is 2. Okay. Now, it says on the right-hand side, what is the ratio of the areas of both shapes? That's a little more difficult. So the area of the left-hand side is simply 15 times 9. What's 15 times 9? Well, I'm going to help you guys out with this. 15 times 9 is 135 inches squared. On the right-hand side, the answer, after you multiply the length times width or base times height, is 60 inches squared. So, we know that the area of the left-hand shape is 135. The area of the right-hand shape is 60 inches. Okay, let's write this as a ratio. So the ratio is 135 for the left-hand shape. The ratio of the right-hand shape is 60. Let's simplify this. I think the biggest number off the top of my head that goes into both of these numbers is 5. 135 divided by 5 is 27. 60 divided by 5 is 12. Can that still be simplified? Yes, it can. I think 3 goes into both 27 and 12. 27 divided by 3 is 9. 12 divided by 3 is 4. I think that's the answer. I want you guys to look at the connection between the left-hand number of 3 over 2 and the right-hand side, 9 to 4. What's the connection? They're not the same like perimeter. What's the relationship between 3 and 9? What's the relationship between 2 and 4? Well, if you guys don't notice it, we've actually reviewed this at the very beginning of this lesson. If you notice, 3, if I squared it, gets me 9. 3 times 3 is 9. If I squared the bottom of 2, 2 times 2, that is equal to 4. So, what's the connection? I want you guys to write this down. The ratio of the area is the square of the ratio of the sides. The ratio of the area is the square of the ratio of the sides. Because 3 squared is 9, 2 squared is 4. That's the relationship. It's different from perimeter. Perimeter is easy because it's the same thing as the sides. However, for area, it's the square of the sides. Let's see if you guys understand this fully. Let's go to the next slide. Okay, we're going to do the same thing. So I'm going to pick 2 corresponding sides. And I'm going to find the ratio. So I'm going to pick the 2 smallest ones. That's easiest for me. That's 8 to 4. What does that simplify to? Well, you have to keep it with the number on the top and the bottom. This simplifies to 2 to 1. What's the ratio of the areas? Well, the area of the left-hand shape is 8 times 9, which equals to 8 times 12, which equals to 96 inches squared. So what's the right-hand one? Well, that's 4 times 6, which equals 24 inches squared. Okay, let's figure out the ratio of the areas. That's 96 to 24. What goes into 96 and 24? I'm going to help you guys out. I believe 12 goes into 96 and 24. 96 divided by 12 is 8. 24 divided by 12 is 2. Can I simplify this further? Yes, I can. If I simplify this even further, it becomes 4 to 1. Now let's see if you guys see any connections to the previous example. You guys should notice that 2, if you square it, gets you 4. If you look at the bottom, 1, what's 1 squared? The answer is 1. So what's the connection between the ratio on the left-hand side and the ratio on the right-hand side? Again, it's this. The ratio of the areas is the square of the ratio of the sides. Okay. Let's see. We've figured out the ratio of the perimeters and the ratio of the areas. Let's summarize this right now. So, this is what it says on the top. The ratio of the perimeters of two shapes is the same as the ratio of the sides. How about for the next one? The ratio of the areas of two shapes is the square of the ratio of the sides. Okay, I know this is a lot to absorb, but let's see if you guys can get some of the problems and the examples. Okay. So this is practice. I want you guys to do this with me. If you guys want to do it on your own and then check later, go ahead. It says here in the example, the two figures are similar. Find the ratio, small to large, of the perimeters and of the areas. So I want to do the ratio of small to large. So what I'm going to do at the top is just figure out the ratio of the sides. So on number one, the ratio of the sides is 5 to 9, small to big. So what's going to be the ratio of the perimeters? What's the ratio of the perimeters? Well, didn't we say that the ratio of the perimeters is exactly the same thing as the ratio of the sides? Yes, it is. I don't need the other sides to figure out perimeter. All I need to know is what the ratio is. Number one, the ratio of the perimeters is exactly the same thing as the ratio of the sides. So it's also 5 to 9. So what's the ratio of the areas? Well, if you guys remember from the previous slide, I said that the ratio of the areas is the square of the ratio of the sides. So all you have to do is take the square of the top and bottom number. What's 5 squared? The answer is 25. What's 9 squared? That's 81. So the answer is this. The ratio of the perimeter is 5 to 9. The ratio of the areas is 25 to 81. Let's go to number 2. I'm going to start off by doing the ratio of the sides. What's the ratio of the sides for this example? Well, it should be 3 to 7, small to big. Okay. What's the ratio of the perimeters? Well, isn't that the same thing as the ratio of the sides? Yes, it is. It's just 3 to 7. So what's the ratio of the areas? Well, like I said before, isn't it just the square of the ratio of the sides? Yes, it is. What's 3 squared? 9. What's 7 squared? 49. Can that be simplified? No, it can't. So that's the answer, guys. The ratio of the perimeter is 3 to 7. The ratio of the area is 9 to 49. That's it. Okay, let's go to the next example. How does doubling the side lengths of a triangle affect its area? Let's just do, we're going to do this tomorrow. Let's skip this. All right. Number 4, it says this. The ratio of the corresponding side lengths of two similar rectangles is 4 to 5. What is the ratio of the perimeters? Well, didn't we just say that the ratio of the perimeters is the same thing as the ratio of the sides? Yes, it is. So the answer for this is simply 4 to 5. So part B, what's the ratio of the areas? Well, it's just a square of the ratio of the sides. So what you guys have to do is just square both 4 and 5. What's 4 squared? 16. What's 5 squared? 25. Letter C. It says this. This is where you guys have to pay very, very close attention. It says this. The perimeter of the larger table is 44. What is the perimeter of the smaller table? Well, first of all, what's the ratio of the sides? What's the ratio of the perimeter? Well, isn't the ratio of the perimeter this? What I'm going to do is write a proportion. The ratio of the perimeters is 4 to 5. This is going to help me solve the problem for letter C. If I know that the ratio of the sides is, of the perimeters is 4 to 5, that's going to help me. If it says the perimeter of the larger table is 44, what is the perimeter of the smaller table? So let's look at 4 to 5. Of those two numbers, which one should be the bigger table? Well, it should be the 5. So I'm going to write this. 44. 4 to 5 is the ratio of the perimeters. 44 is a larger one. And what I'm going to do is figure what x is equal to. So, to save us time, I'm going to solve this for you. I'm going to cross multiply. I get 5x equals to 88. Not 88. 4 times 44 is 176. So what is x equal to? We're going to divide both sides by 5. 176 divided by 5 is 35.2 feet. That's the perimeter of the smaller shape. Okay, I know that was tricky. I'm hoping you try your best on the homework tonight. Well, let's try one more example. So, this is what it says. The figures are similar. The ratio of the perimeters is 5 to 9. Find x. So I'm going to write 5 to 9 like a fraction. 5 to 9. 5 indicates the smaller shape. 9 indicates the bigger shape. What I want to figure out is the side of the smaller shape. It says that the ratio of the perimeters is 5 to 9. And I also know that the ratio of the perimeters is exactly the same as the ratio of the sides. Therefore, I could write a proportion to help me solve this. 5 to 9 is the ratio of also the sides. So I can write 5 to 9 is x to 30. Why did I put x on top and 30 on the bottom? The reason is the smaller number should be on top because 5 is on top, and the bigger number should go to the bottom, which is 30. And I know that 9 is bigger in the bottom. So 5 to 9 equals x to 30. I'm going to now solve this. I can actually simplify. 9 and 30. What goes into 9 and 30? I believe 3 does. So 9 divided by 3 is 3. 30 divided by 3 is 10. What I'm going to do now is cross multiply. 3 times x is 3x. 5 times 10 is 50. So to actually solve this, to save us time, I'll tell you what the answer is. If I divide it correctly, my answer should be 16.6 bar. That's the answer. Okay. So your homework is very similar to these problems. Try your best. If you're confused about this, look at your book or replay these notes tonight at home. Please do your homework tonight. There should be no reason why you can't do the homework. I gave you guys a book already. Please do the homework. I'll see you guys tomorrow.